Every time I see this hot surface, alright, first thing I think of is, why blue? Why not red? But anyway, this thing here, first thing that always gets to me is that looks like a stylized dog. You know, the dog's head here, the front legs here, here's the dog's back legs and his tail. And what he's doing is doing the Pikachu over the fire there. But when you look really closely, it's thing, isn't it? Yes, it's thing. Got normal, standby, alarm, and thermal alarm. So, two sorts of alarms. Someone was asking about specs on the thing. This is like simplistic marking at its best. You know, the arrow up here, AC comes in, DC goes out, you know. Here, this much AC, this much DC goes out. And it's a rectifier. Down here on the specs, okay, you can see there 7.2, 54.5 volts, but the rating is 48 volts out. So that gives you the sort of overrating capacity of the machine, that it can do this, but it's capable of like 10% more than what it's saying. So these would be about 10-15% output overrated at a guess. Of course, the reason we're here is we know we've got some soggy RIFA caps in there that are going to go ballistic if we feed them 240 volts of VAC. And so we're going to have to pull it down. But we may as well have a look at things, because I've done this shit before, actually making production assembly plans and shit like this. You can see here, they haven't just used an off-the-shelf heatsink. They've actually gone out and got someone to make them this extrusion with these wide gaps along here to facilitate assembly. So it's just not off the shelf. Over in the corner here, they had to cut a section out. They've actually milled it out. But, right, I don't know if you can see it. Right on the tips here, where the milling machine would have gone in, the milling head, someone's come along with a file and just hand finished those sharp edges off. Nice. But anyhow, oh, zoom out, damn you. So we have to remove these screws. Okay. These screws hold the diode and MOSFET switching carriers. So these screws come out first. So screws out, and we can flip her over. Then we can remove the top, and then we look for the next. You've got one screw here holding the full wave bridge. Wait until you see the footprint on that, that's pretty interesting. Another one in there. Where is that screwdriver? There you go. Another one in there that holds one of the diode bridges, double diode. Another double diode hole over here, and a standoff screw there. So all of these have to come out. And more about that chip later. This one here. This is an interesting chip. But these screws all have to come out. See the footprint on the bridge rectifier there, sort of normal spacing down on this side, but close spacing up this side. Of course, I suppose they didn't want to put the fuse somewhere else. Interesting. Okay, so that screws out next. So that screws out, and that screws out, and that screws out. This screw in the bridge rectifier, not only did it take some whack to get it out, the screw through there is alloy and non-ferrous for some reason. All the rest just normal screws, but that one was a non-ferrous screw, and they just would have done that for something. Anyhow, that's all the heatsink undone. Take the little piece of plastic off there. Now we just have to remove these big posts. And that will allow the circuit board to lift away from the heatsink. One imagines. After undoing that, which I've just done. So now I won't forget. So it occurred to me that it's easy to take the plate off, so you don't have to muck with the LEDs. Getting them out of the way. All the posts are gone, and then the whole board's loose on the heatsink like this. So now I'm just going to have to prise it up. Of course, it's just the thermal compound holding it there, so camera off and two hands. After pulling a few phases and holding my tongue this way and that, of course they haven't been run, the thermal compound's still really wet, and so it's a real bugger to get the plates off. The easiest way is to just slide the whole board like that off the heatsink, and then it just comes away without putting any undue stress on stuff. And you end up like this. I've actually weighed this heatsink, and she's 950 grams worth of metal. See down here, they've actually potted the thermistor into the middle of the heatsink rather than just use a screw clamp to hold it on the heatsink, so that's a very much better idea. The two diodes have got micro washers under them, so we're going to guess that the cases on them are hot, and so don't overlook that. Over here it's like a swimming pool of thermal compound. It's just everywhere you need it, as much as you would ever need, and like I say, because she hasn't been run, she's still very wet. Even up here you can see how wet the transfer compound is. But like I say, a bit of a skimp on the diodes, but I reckon they're probably not doing that much work. Plus mic is a pretty good thing for that anyway. But yeah, now she's all apart. Wait for the parts to get here, and then we'll go further.